All right, guys, we are on 11.7, day 2, product and quotient of complex numbers. Here we go. So to find the product of two complex numbers, if they are in, like, for example, this is already in these guys, these two here. Sorry, let me switch colors. These two right here, Z1 and Z2, they are already in polar form. If we want to find the product, literally all we have to do is multiply our radii and add our angles. Sorry. So for the product for this right here, Z1 times Z2 is going to be equal to, all I'm going to do is 3 times 2 times the cosine of pi over 3 plus pi over 2 plus that should be that. I sine pi over 3 plus pi over 2. And then I just kind of simplify. And the nice thing is, guys, when it's already in polar form, it is literally just that easy. So it's going to equal 6 times the cosine of 5 pi over 6 plus I sine 5 pi over 6. Remember, that is polar form. And remember, in polar form, our radius is going to be positive, and our angle is always going to be in between 0 and 2 pi, but we're good. Oops, sorry, 2 pi, but we're good there, so we don't have to deal with that. If I wanted rectangular form, the A plus BI format, right? Guys, remember, all you're going to do is actually find the cosine of 5 pi over 6 and the sine of 5 pi over 6. That is, cosine is negative radical 3 over 2, and sine is 1/2, and then you just distribute your 6 across, right? Okay, and I don't think I said this when I was converting them back and forth in that other video, but remember, guys, if it's not an angle that's on the unit circle, just use your calculators and get a decimal, okay? Crap. I added a new page. I didn't want to do that. Sorry. You right? What did I do now? Oh, there we go. All right, so here's what you can do. This is actually in rectangular form, okay? And what I just showed you, it has to be in polar form. When and you would actually pay attention to your directions. Some of them are going to tell you that you can leave it in rectangular form. Some of them are going to tell you you can leave it in polar form. But I want the final product to be in polar form. Now, the nice thing about this is you can actually multiply first and then convert, or you can convert and then multiply. I'm actually going to multiply first with this one and then vice versa with the next one we do. So all I'm doing is distributing. So I will get a negative 24i plus 24i squared. And remember, I squared is the same as -1. And so when sorry, I went back to that other page. So when I do this here, I will have the product, right? The product Z1 times Z2 is going to be a negative 24 minus 24i. That would be in rectangular form, okay? So I've actually found the product first, and then all I'm going to do is convert, and I'll do it pretty quickly because, there's a whole other video for that. So when you do your R, remember it's the square root of your A squared plus your B squared, and that'll actually give you a 24 radical 2. And when you find your theta, remember your point will be down here in the third quadrant, and so you can do inverse tangent of your B over your A, right? And then ultimately it's inverse tangent of -1. That will give you theta equal to 45 degrees, which is pi over 4. But remember, pi over 4 is up here. You don't want to be there. You want to be in third quadrant. So you're going to add that 180 or the pi to it. And so your actual angle is going to be 5 pi over 4. So when you write it in polar form, it is going to be 24 radical 2 times the cosine of 5 pi over 4 plus I sine 5 pi over 4. Okay, so that is your polar form for that. Okay, this one, I'm actually going to convert first and then multiply, okay? It doesn't matter. It's 6 and 1, half a dozen the other. It's up to you. If I wanted to multiply first, just remember that you'd have to do 2 plus 2i times radical 3 minus I, and you'd actually have to use double distribution and FOIL that out, okay? But here's what I'm going to do. Z1, okay? R is going to be the square root of 2 squared plus 2 squared, which is going to be 2 radical 2, okay? And if I were to graph that point, it's a positive A, positive B, so it's going to be in the first quadrant, and I'm just going to do inverse tangent of 2 over 2, right? And that'll give me theta, and so theta will actually give me pi over 4, and that's totally fine because pi over 4 is in the first quadrant. That's exactly what I need. So I found my R, and I found my theta for Z1. For Z2, I'm going to do the same thing. Going to find the R, so R is going to be the square root of 3 squared plus a negative 1 squared, right? And so when I do that, that's 3 plus 1, so R is actually going to equal 2. So there's my R. And then just a kind of quick reminder, when you go to do this, that's going to be down in the fourth quadrant over here, right? And so to find the angle, inverse tangent is going to be the negative 1 over radical 3. Remember, it's B over A. Or, guys, remember, when in doubt, just, actually draw your little triangle. And we went radical 3 to the right, and we went negative 1 down, and we want to find the tangent of that angle. So it's the same thing. So that's going to equal our theta. And so then I'm really sorry, this stupid pen that used to be awesome sauce and not actually, would ignore any of my hands or wrists or anything like that. It's being such a jerk lately. I don't know what's going on. So, when you do this, I should have actually labeled these R1 and theta 1 and R2 and theta 2. I apologize. So theta 2, I'm going to write it, okay, as negative pi over 6. Your calculator should give you negative 30, okay? And I know that what I said was, okay, wait a minute, we've got to make sure that we always have our angle is going to be positive, so you would actually add 2 pi to all of that. But no, you're not going to do it this time because it is technically the correct angle, right? Oops, sorry. I don't know what that's doing. Good grief. Okay, stop. Oh my gosh. I don't want to do any of that. Get out of here. You're killing me. Oh my goodness gracious. I'm really super sorry, dudes. All right. So I don't know. It's my iPad. I don't know. It's got to be my pen. I should not say pen. I should say stylus. But anyway, long story short, you're going to leave that theta alone because it is technically the correct angle. Okay. It's not written in standard form the way we actually write it, but we just leave it alone for right now. Okay. So what you do is when you are doing the actual product, okay, so Z1 times Z2, it's going to equal, all right, you take your R times your R1 times your R2, so you take your R's, so 2 radical 2 times 2, right, times the cosine of, and then you add your angles, pi over 4 plus negative pi over 6, plus I sine, and same thing, pi over 4 plus negative pi over 6. Oops. So what ends up happening is you get 4 radical 2 times the cosine of, this is pi over 12 plus I sine pi over 12. Oopsies. Okay. So you notice how this angle pi over 12, I just pressed pause instead of highlighting that. Sorry about that. That is pi over, that is actually pi over 12. Then that's okay because it's in between 0 and 2 pi. If I had changed that original angle to be positive, which would have been 11 pi over 6, it would have ended up changing this angle, and then I would have had to subtract 2 pi again to get 1 pi over 12. So it's really honestly just as long as it's in the correct quadrant, just leave it alone, and then just make sure that your final angle is okay. Oh, come on. All right, blank screen. Okay, quotient. Quotient is, honest to goodness, kind of the same thing as product, except instead of multiplying your r's, you're going to divide your r's, and instead of adding your thetas, you're going to subtract your thetas. So looking at this one, I am going to do, for the quotient, right, if I write z1 divided by z2, it's going to be 1/7 divided by 1/8 times the cosine of, and then you just subtract those, 2 pi over 3 minus pi over 4 plus I sine 2 pi over 3 minus pi over 4. Okay. And then when you write it all simplified out, okay, pen, good grief, you get an 8/7, right, times the cosine of 5 pi over 12 plus I sine 5 pi over 12. Okay, and again, that is in polar form. If I wanted the rectangular form, because 5 pi over 12 is not on the unit circle, I would just make sure my calculator is in radian mode, and then I would just do 8/7 times the cosine of pi over 12 and get a decimal, and 8/7 times the sine of 5 pi over 12 and get a decimal, and then write it as, you know, a plus bi for rectangular. All right, this is in rectangular form, and I'm actually going to divide and then convert. So 4i divided by a -6 plus 6i, I want to do it on purpose. I mean, I did, for your PDF notes, it's done in both ways. So you can see the conversion first and then dividing, but I wanted to do the dividing first and then converting because I wanted to remind you of what really has to happen when we are dividing by complex numbers. You need to multiply by the, oops, crap. Again, pen and not doing well with the, whatever, the palm recognition or palm rejection or whatever it's supposed to be doing, where it's not supposed to be messing around like that. But anyway, you're going to multiply both your numerator and denominator by your complex conjugate. And so what you're going to get up top is you're going to get a 24 minus 24i up top. I just switched it over real quick. And then in the bottom, remember the whole point of the complex conjugate is so that the actual just plain old I disappears. So when you do first times first, you're going to get a positive 36. Outer and inner should cancel. And then last times last is going to give you a negative 36i squared, right? Which would be a positive 36. So you're going to get a 24 minus 24i over 72, which is a 1/3 minus 1/3 I. So that's actually the quotient, and then I'm actually just going to go ahead and get my r and my theta. So r, oopsies, sorry, grab the highlighter, not the actual pen, sorry. R is going to be the square root of 1/3 squared plus 1/3 squared, right? And so that is really just 1/9, so it's going to be square root of 2/9, right? So it's radical 2/3, right? And then for the tangent, what you're going to have is, let me switch another color. Again, goofball, don't pick the highlighter. So tangent, inverse tangent of, and then again, you just do b over a. So negative 1/3 divided by 1/3. Well, that's just -1, so that's theta. So it's inverse tangent of -1 equals my theta. And when you do that in your calculator is going to give you -45 or negative pi over 4. And if you had graphed that, you would see that it's down here in that quadrant. So it's in the correct quadrant, but remember, you want to write it as a positive angle in between 0 and 2 pi. So you're going to add 2 pi to that and get 7 pi over 4. And so then your quotient, z1 divided by z2, is just going to be radical 2 over 3, which is your r, times the cosine of 7 pi over 4 plus I sine 7 pi over 4. And that's that. Now, this is in your PDF. I just wanted to say a couple quick things. You can convert first and then multiply or divide, or multiply, divide, and then convert. It is 100% your choice, okay? Now, honestly, sometimes it's just easier and faster to multiply or divide first, because then you only have to worry about converting one, the actual, like the already product or quotient into polar form, and that's fine. I don't know. Sometimes I think I always just do one way or the other, but I don't. It's just random with me. And when you are converting, okay, if you're doing the whole convert first, watch your angles, please. Be sure to use the correct ones in the correct quadrants. Like I did with the example where I said, okay, let's use negative pi over 6, but then make sure that your final, when you do theta 1 plus theta 2 or theta 1 minus theta 2, that has got to be between 0 and 2 pi.